Simulation, the engine of Industry 4.0. Welcome to our presentation on the pivotal role of simulation in Industry 4.0. We'll explore how virtual models are transforming industrial processes, driving efficiency, and enabling the factories of tomorrow. By Balaji Jayaraman. Defining Industry 4.0. Industry 4.0, the fourth industrial revolution, integrates cyber-physical systems, the Internet of Things, IoT, artificial intelligence, AI, robotics, and big data. Its goal is to create smart, flexible, and efficient industrial ecosystems, capable of self-optimization. Core technologies of Industry 4.0. Internet of Things, IoT. Interconnected devices collecting and exchanging data. AI and machine learning. Enabling intelligent automation and predictive analytics. Robotics and automation. Advanced robots, performing complex tasks autonomously. Cloud computing. Scalable data storage and processing for industrial applications. Digital twins. Virtual replicas, mirroring physical systems in real time. Cybersecurity. Protecting industrial control systems from threats. Understanding simulation. Simulation involves creating a virtual model of a physical process or system. This allows engineers and business leaders to test, predict, and optimize operations without disrupting real-world production. Let's look at the different types of simulation. Discrete event simulation models events that occur at specific points in time. Continuous simulation models systems where state variables change continuously over time. Agent-based simulation models individual autonomous agents and their interactions. Hybrid simulation combines multiple simulation approaches for more complex systems. Simulation's role in Industry 4.0. Enabling digital twins. Simulation provides the predictive capabilities for digital twins, allowing real-time mirroring and analysis of physical assets. Process optimization. Engineers can optimize production lines, logistics, and resource allocation in a virtual environment before physical implementation. Safe AI/ML testing. AI and machine learning algorithms can be safely tested and validated within simulated environments, minimizing real-world risks. Training and skill development. Virtual reality (VR) and augmented reality (AR) simulations provide immersive training for workers, enhancing skills and safety. Digital twins and predictive power. A digital twin is a virtual replica of a physical system, process, or product. Simulation provides the critical predictive capabilities for these twins, allowing engineers to forecast performance and potential issues. This real-time data integration supports informed decision-making, such as predicting equipment failures for proactive maintenance in manufacturing, thus minimizing downtime and operational costs. Optimizing smart factory design. Simulation is crucial for designing smart factories. It enables the virtual modeling of production lines, overall factory layouts, and even workforce planning. This allows engineers to evaluate proposed changes and new configurations without disrupting current operations. Improve manufacturing throughput by identifying bottlenecks. Reduce waste by optimizing resource utilization. Streamlining supply chains with simulation. Supply chain simulation allows businesses to model complex logistics and potential disruptions, such as sudden demand fluctuations or supplier issues. By leveraging predictive analytics, companies can optimize inventory levels, streamline transportation routes, and mitigate risks, ensuring resilient and agile supply chains, even in volatile markets. Human-centric simulation for training. Immersive training. AR/VR simulations provide realistic, risk-free environments for workers to practice complex tasks and operations. Ergonomics and safety. Simulate human-machine interactions to optimize ergonomics and identify potential safety hazards before they occur. Faster onboarding. Reduce training time for new employees and ensure compliance with operational procedures through virtual practice. Case studies and conclusion. Real-world impact. Siemens utilizes digital twin technology for predictive factory management and optimized production. Airbus employs extensive simulation for aircraft assembly line optimization, improving efficiency and reducing errors. Bosch integrates robot simulation for precise smart automation and collaborative robot deployment. Key takeaways. Simulation is a foundational pillar of Industry 4.0, driving innovation, efficiency, and agility across all industrial sectors. The future promises even more autonomous and AI-integrated simulations, further transforming manufacturing and operations.